Hello students, how are you all? I hope you all are fine. So in last video, we had discussed about the types of function. Okay, so we had discussed about the type of function with various examples and with mapping also. Okay, so there is one function, many one function, onto function, into function. So when you will when you will tell ki particular function is one function, which one is many one function, which one is onto, which one is into, bijective, surjective, injective, everything I told you in last video. Okay, so see here one example is written. On the basis of this example we will discuss some about the types of function. So see here what question is saying. In each of the following cases state whether the function is one. Here two cases are written, one this one and one this one. Okay, so what case is f such that r tends to r defined by fx is equal to 3 minus 4x. And here second one f dash f such that r to r tends to r defined by f x is equal to 1 plus x square. Now you have to tell ki whether state whether you have to tell ki it is one function or onto function or bijective or both. Okay, you have to tell about this also. Okay, so and justify your answer. You have to justify your answer why it is one, why it is onto, why it is bijective. Okay, with reason you have to tell. So let us start. Okay, so let us start first one. First one is f such that r tends to r, sorry, fx is equal to 3 minus 4x, and here condition is written f such that r tends to r. Okay, so see here you have to put real values. Okay, so we have to see the one function onto function. So one function means what? See, one and onto function means what? Suppose 1 2 3 element is given, a b c is given. So if every element have single, means every element have unique image. Okay, and no two elements are there have same image. Okay, then that function is called as one function. Second thing, if in the second set no element is left to be mapped, then that is called onto function. Then this is one also and onto also, means in the second element, in the second set no elements would be left to be mapped, and one every element have a single unique image and different image. Okay, not same image. So see here it is written. And one also is called as injective. One is also called as injective, and onto called as surjective. Okay, and if both is there, then that will called as bijective. Then that will called as bijective. So now let us see. So whether this function is one onto or bijective. So let us see if fx is equal to, means uh, how you will know this about whether it is one or onto. So you will put the value of x. Suppose that if you are putting 1 in place of x, if you are putting 1, then what you will get? 3 minus 4 minus 1 you will get. See here. Second thing, suppose that if you are putting minus 1, okay, if you are putting minus 1, then what you are getting? Minus 4 minus a plus 7 you will get. 7 you will get. Okay, so check for the 2 also. If you will put 2, 2 4 is 8, 8 minus 3. So minus 4, minus 5, 2 minus 5 you will get. Now if you will put minus 2, suppose, so 2 4 is 8, 8 3 11, 11 you will get. So see here. So every element have unique image and different image also. So this is showing what? This is showing what? One function. This is showing what? One function. Okay. Second thing, we will check for the onto. Onto means no element should be left here to be mapped. So you can see every second elements are real number. Every second elements are real number. Real number. Okay. So every element mapped, every element of second are mapped. Okay, no element, no element will left, will left to be mapped. Okay, so here no element will be left to be mapped. Every element of second will be are mapped. Okay, so that's why it is called onto function. Here one function, here you will give the reason what key every element have unique and different image, unique and different image. Okay, that's why it is called one and it is called onto function. Now if both is there, if both is there, then what will we say? See, this is bijective also. Bijective means if you will take, suppose that if you take fx is equal to y, then it will become 3 minus 4x. Now write this in the term of y. So x will be what? 3 minus y upon 4. You can write this x is equal to 3 will go 3 y will come this side, minus 4 will come this side. Now x is equal to 3 minus y upon 4. Now if you will put 1, suppose you are putting 1 and 2 upon 4, again real value will come, not imaginary. Okay, any value will put in the place of y, then you will get the real value only. Suppose I am showing, suppose you are taking 0, suppose y 0 you are taking, then 3 upon 4 will come. Suppose you are taking 1, okay, so 2 upon 4 means 1 upon 2 are coming. Means every time on putting real value you will get real value. Okay, on putting real value you will get real value. Okay, not imaginary value. If imaginary value will come not, then mapping will be not done. Okay, so see here, in this way we will tell ki this is one function also, onto also, and bijective also. Now we will see for the next one, second one. Second one is what? Fx is equal to 1 plus x square, and f is such that r tends to r. Same thing is there, but here function is different. So remember that in last video when I was discussing about the types of function, I have discussed about the x square. Suppose that if fx is equal to x square is there. Okay, so in this, on putting 1 you will get 1. On putting 1 you will get 1. On putting minus 2 you will get 4. On putting 2 you will get 4. So you can see two elements have same image, means in this mapping are coming what? Minus 1 1, minus 2 2, 1 4. See, see here what you are getting. The two elements have same image, not different image. Have unique image, it is function, but have different image, means this is many one, this is many one, then it is many one, then not one one, then not one one. So here you will write what? See here plus 1, then if you will add 1, then it is also to not not 1 1, not 1 1. Okay, not 1 1. Now we will check about the onto. Onto means what? Ki on putting real value you will get the real values. Okay, on putting real values you will get the real values. So see here, uh, sorry, onto means no element should be left to be mapped. Okay, no element should be left to be mapped. So how you will check? So in this you can see between 1 and 4 there are so many elements, 2 4 2 3 are there, है ना, that are getting left. Between this 2 3 are there real values that are getting left to be mapped. Okay, so it is not onto, so this is not onto, not onto. Why it is not onto? Because element of second left to be mapped. Okay, to be mapped. See here, in this way you will write. Okay, now if you talk about the bijective, bijective, if it is not 1 1, then not 1 on 2, then bijective, not bijective also, not bijective. If you want to see in another way, then write what is there, huh? Fx is equal to y is equal to 1 plus x square. Then what will come, see here? So x is equal to what will come? Y minus 1 square root, and square root value is plus minus 1. See, if you will put the real values, suppose that you are putting real values, then what is the condition key? You will get the real values only. So you can get imaginary value. Suppose you are putting minus 1, then you will get minus 2, square root of minus 2. See, and square root of minus 2 is what? Imaginary. What? Imaginary value, है ना? Imaginary number. And here imaginary number will not consider. So see, it is not bijective. In both ways, in two ways you can tell about the bijective. First one, it is not 1 1, not on 2, so it is not bijective. Second thing, in this way also you can tell. Okay, bijective means in both ways. If you are putting the value of x or you are putting the value of y. Okay, means if you are considering x as domain or you are taking y as domain, in both ways conditions should be fulfilled, but here conditions are not fulfilled, so it is not bijective. So in this way you can see, in this way you will tell key which one or one on two and bijective. Okay, so I hope you have understood this question. Okay, so in next video I will come with one more example to make you understand in a better way about the type of function. Okay, till now wait for the video. If you have liked the video, then share and subscribe it. Okay, and till now thank you. Wait for the video and have a nice day. Okay.